Hello, and thank you for joining me. You're here with Data Science Teacher Brandyn, and we're on our fourth part of our stock prediction project series. Okay, so the LSTM stock prediction series. Okay, so here we're going to continue predicting the Google stock price. This would work for anything. Might need to change a few pieces of data. Today we're going to be doing something special and using the functional API to build a little bit more complex deep learning model than we have in the past. So we're also going to be combining three different sets of data. So one from the historical time series, one from the economic data that we've used in the last class, and then one for the trends, just Google searches. How much are people searching things like recession, find work, and the two stocks that we're trying to, or the stock that we're trying to. Okay, so let's get started and we'll get into it and it'll all make a little bit more sense as we start working. Okay, so first we're going to install TensorFlow underscore add-on. So this is not included standardly. So every time if you're using a Google Colab, you have to run this every time. Not a big deal. So then we can import the TensorFlow libraries. So we're going to import TensorFlow as TF, our other standard data science libraries. And then we're going to go TensorFlow add-ons. And for this, we'll import it as TFA. And we'll need it for one thing today. Okay. So we're going to import some optimizers from Keras because we're going to use them in the loops down below. So when we do this, we're going to go SGD for stochastic gradient descent. And then we're going to do root mean squared property. So root mean, it's kind of like root mean squared error. I find this one works well on more classic kind of regression problems. This one is actually a good fit. The STG is also good, kind of more the standard one. And another good one is Atom. Ada Delta is technically a more advanced version of Atom, and then FTRL. I don't use that one a lot, but it is used in specific situations, so I thought I'd try it here as well. And it was not the best optimizer, I found out, but maybe you will find differently. Okay. So here, my data set, or the Google data set as it's always been, is in my GitHub reservoir. So that, load that up, and you see here we have standard date, open, high, low, close, adjusted. So we'll be looking at the close value as what we're trying to predict, and our dates. We'll also use this to join our data based on the dates, which is really good. It's one thing when our data sets are so different, we have to consider what is the same thing between all of the data sets that we can then join it on. And as we're dealing with a time series, the date is really good starting point. So here, just loading up the economic data. We did this last time, so I won't spend a lot of time on this. So uploading the economic data, I did include more features this time. And so when I did, the thing was I accidentally included a couple extra ones. I included employment rate twice. You can see this here. When I look at the columns, you can see 0.1, 0.1. And that just means I included it somewhere else. If we're looking at employment rate, you'd probably find it somewhere up at the top. And so I accidentally included it twice. And I did that the same thing for trade balance. And we also have this extra unnamed column that we want to drop. So we'll just do GDP df dot drop, and we're going to do this across the axis 1 because we want to drop the columns, not just rows. Okay, so we're going to drop these columns. Okay. So got that done. So cleaned up the the economic data. Okay, what I had to do here is make a little function to essentially change the column names from here. So what I'm going to do is df.columns, and this will make more sense. I'll show you what it looks like as we import one. I did not know this before I looked at the data frame. This is not magic, I guess I would say. So I saw the data frame and I realized I did this. So I made this before I imported the data just to kind of keep things neat and clean. Okay. So I'm going to set the columns as the first row, because what happens is the column names aren't the greatest, and the first row is actually what I'd like to set the column names to be. Okay. And this has to do with something about the weird thing about I just imported the data and the file as is. I didn't make any changes so that it was kind of the realist sense of doing it. So then I'm going to go drop, and I'm going to drop the row with the title week because that's what we don't want. We don't want week as the index, so say bye-bye to that. And then we'll set date to, because we're going to want to join on this date, and we can do it two ways. If they're all indexes, we can join on the indexes. if they're just a column, we have to make sure every single one of our data frames has this as a column. Okay, so we're just setting here now our index, which is our dates. We're going to set that to a value in our column, or a column value, so that we can merge, we can join on like a SQL join on that. And so after we clean up, we're going to pass our data frame, and we're going to clean up the data frame, and then we're going to get it. So that's our little function. So we'll use that just down below, and I'll show you why we created that after we import the data. Okay, so here what we're going to do is pd.read_csv. Have the parentheses, so I don't need those. Okay, and I make sure it's pd.dot. So I'm going to be lazy right here. It's really good to always write out your functions each time, but since I've worked with this data before, I've done this many times, read CSV, just trying to go quick, we'll just copy and paste those. Okay, so there we go. So we'll import all three of those, and let's look at what the first one looks like. Okay, so again, this is, okay. So here what we're going to do is we're importing all of our data sets here. And we see that recession is incorrect here as well. So this is not what we want. We want this to be the column title, and we want week. Well, we want to change this to date, but we would like this to be the column as well. So this is technically the index right now, and this is the columns right here. So we don't want, that's why we did this index. We're setting this, the date values, to another column, and we're going to move recession into the column title. So as we combine many of these, we'll be able to do this. So we are going to do the df cleaner. Oops, I gotta spell that correctly. df cleaner, and df cleaner, and then df. So this is the function that we made. Okay, and so we're going to run those, and so we can see what it looks like before and after we run this. We're going to get not the best. It's still a little dirty. Still some stuff to do, but we got a starting point. So now we have this US recession. So this means that when I was looking for the trend word, the Google search word recession, it was in the US because we're predicting a US stock, and that made no sense. Maybe it would be interesting to include the global recession searches. Anyways, but here we're focusing on the US stock. Okay. So then what we're going to do, so we have those three data frames. We're going to concat those three. So we're just going to, and we're going to do it with the defaults. All the defaults, we're sticking them together the long way, so kind of vertical. So we're sticking them this way. They're always going to pile in that way. We're going to have different recession values, but we'll be able to have different, but we'll have the same date column. So we clean these up to be kind of exactly the same. Okay. So we'll do that, and we got all of our columns here. So now we have our full data set here. So this is just the DFR for the DF recession. It's only for DF recession. So we just pile all the weeks in. We just keep stacking it in. I couldn't download a bigger one at once because it did it by month. And I thought, stock markets are daily. The best I could do was get the search terms weekly. And so I did import it in 3 for one search term to get a long enough time frame. So here what we're doing is we're just sticking one search word together to be the full time frame. And now we have 783 rows. Okay, so we're going to do the same thing for each one of these. So we're going to do the same thing. We did the one for recession. We're going to do one for we're predicting Google stock. I wondered if the amount of times Apple, the stock Apple, NASDAQ, ... Apple is searched for might have something to do with the stock. And so we'll see. So I did, again, it was just a complete experiment. There's not an exact science here. We're experimental scientists, and it's an experiment to see what works. So I'm doing the same thing again now for the Google price. Okay, and then doing the same thing. And I thought another thing related to jobs would be good. Recession was one, but maybe find work could be another good search term. And maybe there's another search term you can think of. So just noting that again, I did these each search term in 3 parts, and we had to upload the data. Okay. So, and here I'm noticing it's actually still in my Google Drive, but I will put this into my GitHub reservoir for all of you before this is done. So then what we're going to do is we're going to merge our trends data. So we're going to go all through this. So we're going to go pd.merge. We're going to do the recession one and then the Apple one. And we're going to create trend from that. So we're creating a new data frame. In the next one, we're going to merge the trend data frame, which is the 2 Apple and recession, with Google. And then we're going to merge that as well again with W, which is the find. Okay. And so this is, every time we're going to merge on the date column. So it's going to not duplicate the date column, it's going to merge on that one. And so what's that? So we merge them and we have a full data frame. Now, unfortunately, it's still a little messy. And so what I wanted to do is clean this up. What I wanted to do specifically is get rid of this United States, kind of ugly, truthfully. It's just unnecessary in the column names, and just big column names kind of ugly. So what we're going to do here is we're going to do str dot. This is a really good example of something that can happen here. So when I do this, so what I'm doing is I'm taking the column names, I'm putting it into a series so that I can use, and I have access to the dot string dot replace function in pandas, that I can replace this whole thing right here with just nothing, just getting rid of it all. And so let's see what happens, and it does not work. Okay, not a surprise for me, but the reason it does not work is because these parentheses are special characters. So to tell Python to ignore those special characters, we have to put a slash. This is the backslash in front of it. So what we're going to do in the next line is we're going to do it correctly. So we're going to go df columns, df trend columns. So we're changing the trend column names to PD. We're putting in the column names in a series. We're going to put that into a string dot replace. So we're going to use the replace function. And we're going to replace United States with just nothing, essentially just get rid of that column here. And so now we get nice neat columns. Super minor, but super helpful when we're building a workflow. Okay, so here what we're going to do, now we've added all these things, we've got to, because the way it started when we took the first row and made it a column name, but that first row was in there, so string was included in the column. So all the data types got set to object, not the correct data type. So we're just going to reset them here. So we're going to do column is equal to, well, df trend column equals df trend column dot as type, and we're just going to change as type for all of these right here. As type for NASDAQ as type int, and then as type int as well. Okay, so we change these now all to as type. So we run this again. You'll see now we have one object, which is the date, and we have the other 4 integer columns, which is exactly what we want. Okay. So just looking at the data types for all 3 of these, and we're going to merge all of the data together now. Dun, dun, dun. Okay. So here we were printing the shape of all of them. Right here you can see we got 44,000, 37, 4,400, 3,700, and 700. But the trend still encompasses the full time. So we're going to have to do some cleaning to get rid of these null values. Okay. So here, the data frame that I like to work with, I usually just call it df because it's, you write it out so many times, it's easiest to keep it simple. So what we're going to do first is we're going to combine df with df underscore GDP. So the original df is just the historical times. I kept it the same as where I originally created this. I might have called it df time or something like that now, but I kept it the same. So the original df, we're just going to be essentially replacing over that, copying over that. So we're going to put df and df GDP, so we're combining the historical and the historical price of Google stock and the GDP data. We're going to do it on the date, and we're going to do how as an outer join. In the next line, what we're going to do is we're going to create df from that. Then we're going to take df and merge the df underscore trend that we created. And we're going to do it on the date column and how. Spell trend correctly. Okay, so there we go. And we'll see here by this. So we have our Google stock, GDP, trend, Google GDP. So when they're together, we got 4,500. And then when we got our final data frame, we have 5,300 rows. And this is because the one unfortunate thing is the Google Trends date comes out on a Saturday. So there's unfortunately, none of those days. So we'll have to do a few things to get this to work, and we'll take a look, a whole bunch of cleaning, and then we'll get into building, not a whole bunch, but a little bit of cleaning to get into this. So we're going to start by sorting all the data in terms of the date. So it is an object, but it's year, month, day. And so when you sort that, it will just sort in the correct order because it works well in a number. And you got to spell sort values correct. Okay, so sort values. Okay, what I'm doing here is I'm just creating a little data frame. We did this last time, so I won't go through making this random color. So I get bored of the same colors. We created a palette. Which color do I want to use? I'm not sure. Let's just randomly choose that. So this is all is doing, this is r_color, is choosing a random color from this palette. Nothing fancy. And I made the palette a colormine.io just to keep it a little bit interesting. And then every time I run the project, which is many, many times as I'm building this, it's not the same colors every time, which makes me happy. Something small like that. So I will go over this. This is going to say if nothing has been passed to seed, then it's going to randomly generate a seed, and then it'll print out that seed so we know what it is, and we can save the color. We could pass then the randomly generated seed to it again, and this will not happen, and then it will just create the same random state again, and the same random color will be chosen. Okay, so we'll go over that. So this is just to randomly choose one of the colors from the palette. Okay, so using this in a function, I'm going to put the random color, and I just have to index into get the, when it's only one item, get it out of the list. Okay, and so you see you get a different color here. Okay, so what we're going to do, and then I'm putting it into sns.light palette. This is making a palette from the one color, which is kind of something I want to do. Okay, so the first thing we're going to go is df, which is our main data frame now, is null. So df not is null, and I think this is just really valuable because we're dealing with time series. So where our null values are happening is actually kind of important for us to understand. Okay, and this is exactly what we were expecting. So we see some of our economic indicators, they weren't available earlier. You can see that I only collected my economic data up to this point, but then all these other ones, this one comes way out really here, and so we lose a lot of data if we wanted to use that. Okay, so and we're seeing all these lines across here is where there's a null value. So this is to highlight what's happening here is df.isNull is creating trues and falses. Trues are ones, falses are zeros. So the color is a 1 and the falses are a 0. So when we see a green line here, those are null values. This is null because we have a value for on a Saturday, but we have no stock data for that value. So we sorted it. So the stock is right here, or we have the value for the value, and we can see we have lots of values in the trend because we have no values for those on the week. So we're going to have to fill those, and we're going to do a few things to make sure that we do this correctly. Okay, so first, just to start cleaning this up, we're going to df.drop. So we have these 4 columns here didn't really have, they had so many null values that I just figured it's not really worth using those. So we'll get rid of those, and we still have lots of data. Okay, so go to columns. Okay. And so what we're going to do here, we're going to go features, just the features that we're going to use in the next step right here. Not for modeling, but features. Okay. So then what we're going to do is we're going to put features. So df features equals to df features dot f fill. So forward fill. So we're going to fill the null values and bring them forward. So on a Saturday, you're going to know what the release of the Google Trends is, and then you're going to use that value for the whole next week in your predictions, right? That's kind of the best that we can do in this situation. It'd be nice to have it every day, truthfully, but we don't really have that. So. And got to run this cell up above first. See this? And now if we look at this, let's go plot.figure. We're going to do sns.heatmap. And we're going to go sns light. I'm going to try to select the none first. Light underscore. Do that. I'm selecting the one. We're giving it the random color generator to choose my color. So here we go. We got significantly nicer. So the reason that I didn't want to do the value that fill forward the null values, because I'm going to drop these because these are where the target is null, right? It's a Saturday. There's no stock value to predict on a Saturday or a Sunday. So these, we don't want these values. So I only fill forward the economic and the trend values because I want to drop these values where this is what we don't have it because we can't really fill a null value, or sorry, a target value. That's really creates a lot of bias. Okay, so what we're going to do next is so here what we'll do is df df dot not null. So here we're getting rid of, and we're just going to copy this to as professional as possible. So we're going to say when close is not null, assign that to df. So we're going to basically taking the whole data frame, but when it's not null. Okay, so we're going to go figure equal, and then we're going to pass it the big size, and that equals 20 by 20. Okay, and then we're going to go CMap down. Okay, so we're doing the same thing, heat map, giving it the data frame is null, the trues and falses of this data frame. Is really just a convenient way to look at this. Okay, so now we have much more reasonable the amount of null values we have and going forward. Yeah. So got some null values. We have a pretty big amount of Google data. It would be nice to use all of this. We do have the closing values for these, but truthfully, collecting all this data is a pain in the butt, and going back to collect the original economic data, it's a little bit too much. Okay, so it's good. It's good for a reasonable sake. Okay, so here we're just making the indicators as we've done before. I'm going to run through these quickly, just because everything's the same. So we're going to not focus on that. Going through the economic indicators just like we did, cleaning up. There's lots of like the M, the K, the B on billions, M on millions, K on thousands, and the percentage signs need to be cleaned up here. So doing the exact same thing, just noticing I'm not using these two columns this time, so just commenting them out, because who knows, maybe you want to use them. So here we're doing our little time series components. So we're going to analyze our components, and we're going through this. If you remember this from last time, what we're doing, instead of using just the full last 30 days for each one of these indicators, we're reducing the number by which ones show a higher correlation with today's value. So root mean squared we think is correlated, or RSI, so which the relative strength index, it should hopefully help be related with the stock price. So if we think it's related with our stock price, which is what we're trying to predict, we would think then that if it's related with itself in the past, there's kind of a tertiary correlation with the stock price and maybe 2 days in the past, 3 days in the past, 5 days in the past. So that's what it is. Just build a list of all of these. I mean, it went up to 30 days this time, so we've expanded it a little bit from what we've done before, but went through that. And then again, doing the same thing here and looking at all of these. Really interesting. Every day kind of has different patterns here. So you can see here the closing price, the correlation with itself, really strong correlation is yesterday, 4 days ago, and 5 days ago. So yesterday, 4 days ago, 5 days ago, then 6 days ago, 9 days, 10 days ago, and so on. So I just follow that pattern in the hope that these days, this is maybe 16 days versus 30 days, will be better predicting days and won't confuse our model by giving it too much data that has no correlations. Okay, so it's just a way to reduce the number of features we're putting in. They did the same thing for economic data. We're going to use the current value of the economic data. Doing some analysis of the stock market, the values of economic data is usually released at noon, so we would have access to that at the end of the day. So we're going to use today's values as well as some historical values for the economic value, because we should have that all in all most likely before we do the final. Okay, so just drop all the null values next in the next one. Okay, so just going through here and going to look at the null values. Okay, so we get always a different color to make it fun. But here we see where we created the indicators as we're going a little bit farther back in time, and some of the trends right here, and then so we have a little bit of null data, but we're just going to drop those, get rid of those, and then so we'll do df.drop NA, and then shape it. So we are losing some rows, but we actually have a lot for a stock prediction. Usually you're very lucky to have 1,000. Here we had 4,000, 4,400, and we're going down to 35. So not the best, but pretty reasonable. So just looking at this one last time, we're going to do a heat map, df.core, and then cmap equals sns dot. So df, so we should run this now. And wow, you gotta finish spelling the heat map, obviously. And then we go here. Hmm. That was funny. I was really confused what was going on because this does not look like you would expect it was not supposed to, but that's because I did what I normally do in a heat map, df.core. How do I do df.is null? Because that's really what I'm not looking at the correlation matrix right now. I'm looking for null values. So I kind of defaulted into my habit right here. So, and this color, basically, there's no real difference in here. So everything is not null. So we have a data set. So here what I'm doing in the next lines, I just made the list of the columns. The big difference here because we're going to have 3 different inputs coming in different sides in our model at different times. And so we're going to create 3 different series. So we create a time series data that we just did the seasonal decomposition for. We're going to do our Google Trends data, and then we're going to do our economic data. So we're going to have 3 different sections that we're going to deal with. Okay. So run this. And here I'm predicting the fast K. It's what I've always predicted when I predict this sum, where you can choose close, MACD, really anyone to use. But the current value, because we're trying to predict the current value. Okay? And that's why we're using the previous closes, the previous day's indicators to predict today. We can't use today's indicator. Okay, so we're going to start by creating the inputs and outputs. And it's good to think of this as not just X train, Y train, it's input and output, because you're going to have a lot more. You get a little bit more creative with your inputs and your outputs in a functional model. Okay? So we're going to go input TR for train, econ, economic. Then when I'm going to go DF train, and I'm going to go features echo. Okay, so features economic. So run that. And then we have now, this is a data frame of just our training economic features. Okay, and then a data frame of our training time features, and then a data frame of our training trend, the Google search trends. Okay. So we're going to go output underscore train next line. And here we're going to go dftr and target. Target these 2 data frames. Okay. So, and as you can see here, we have the same shape for each one of those. And I did at 3,000 rows. So we have 560, so, good amount. We could almost say we need less to do a prediction, but it's a good start. Okay. So we have 3,000 rows, which is really good for an economic prediction. But it would be nicer to have more testing data, but there's only ever so much data. So here we're going to call a standard scalar. We're going to start off by std underscore scalar. We're going to assign this is going to be the initialization of the standard scalar, and we might as well fit this as we're initializing it. We're going to fit it on the train data. Okay, so we're going to go std underscore scalar. Oops, and then we're going to go transform. Okay, so then we're going to do this. Now, the really important thing to note is that we're reinitializing this each time. And we're going to do the transform for the train and then the transform for the test. So it's learning the parameters to standardize only on the train and then doing for both. But because we're doing 3 sets of data, we're reinitializing the model 3 times and fitting it for the 3 different types of data. Okay. So next, what we're going to do is we're going to go import df from tensorflow.keras import layers. We're going to deal with a lot of layers today, so it's just easier if we don't have to write tf.keras.layers. We're going to start with layers, save ourselves a little bit of time. It is usually written tf.keras.layers, but just to make our lives easier. Okay, so we're going to start with in the first thing. So these are all the different parameters that I set up for these experiments. We're not going to do all these experiments today, but this is how I found a good model by iterating through and creating this setup for experimental, trying different parameters and seeing what we get. So what we do first, so we're going to create the input layer. This is kind of different than the sequential model where you can just define this in your first layer. The input shape is this. Here, we need to have it as a specific layer for a specific reason. So we're doing TF. This is going to be input underscore time. Okay. And then we're going to go TF dot keras dot input, capital I input. And then what we're going to do is the shape is equal to the length of our features. And because this is going into initially into a recurrent layer, it needs the depth. So the Z dimension, X, Y, and Z kind of going in and out. And we just have one spreadsheet, so this is one data. So we just have to say this. You'll have this with a picture. You'll have 3 channels, red, blue, green. So you have 3 this way. With a spreadsheet, you only have 1, but we still have to say that we only have 1. Okay? And then really important in this step that for the inputs and the outputs, we give these layers names. We could give all of our layers names, but we don't need to. But we're going to use this name to reference what data we're giving our model. This data goes to this layer. So this name is really important. Okay. So we're going to go if recurrent type body is equal to LSTM. So we can change names, LSTM, GRU, or simple RNN. We can do all of those. So we're going to do this together. So we're going to do one of these 3 channels together to get started. So we'll go time. So it's going to be our time layer is equal to layers dot LSTM. And the recurrent body neurons is going to be 135. And then we're going to find our activation is going to be recurrent body act. Right? This is what I said it with is starting. And then what we're going to do, so this is very different than the way the sequential marks works, this main step right here. Okay. So what we're going to do, we're taking this first layer and we're going to, it looks like we're multiplying it by this layer right here. But what's actually happening, this is something, a quirk of Python. When you put 2 functions together like this, one actually performs on the inside of the other one. So this allows us to basically have our model kind of go forward. What's actually happening is this layer is running on the inside of the time layer. So it happened, this goes first, then this one. So this is not simple multiplication. This is kind of a little bit more complex Python syntax that's happening here, but it is a quirk of Python, and that's what we're doing here. So we're saying that this input function is going to be performed inside the LST function. So it would be the first thing and then the next thing and so on. Okay. We're going to say that was the LSTM. LF, that was a GRU. We're going to go the time layer again. So we're doing this for each layer depending on what happens in this first situation. We're going to do layers dot GRU. Okay. So gated recurrent layer. I don't know what the U stands for actually, but gated recurrence. This just allows for a little, I find the LSTM works better, but it's good to try kind of all layers. And then again, we would do the input. And you can see here I have input eco, input trend, and the input time goes into the first. Else if we have the recurrent type is SNN, we're going to do time again. The time layer equals to layers dot simple RN. And then activation. This, and we're going to again do the same thing we did the input time. So what's going to happen is depending on which is it LSTM, GRU, or SRNN, simple RNN, we're going to build one of these. We're going to build these 3 layers, or build these 3 layers, or build these 3 layers. So what's happening here is this is the input for time, and then we're creating another time layer that's coming out of this. And then we have the trend and we have the economic data, and they're not multiplied, but they're next to the LSTM layer. They're being performed inside. It's the economic data and then the trend data. So we have to kind of keep track of these. So I call them time, economic, trend, and just to keep track of them. I could have just called them 3 different names I would need, but you can call them whatever you want. Okay. So now that we have those, what I thought would be good is because we have a lot more data for our time series, let's decompose and extract higher level features from that to get started. Okay. So what we do in all situations, that we're going to create a dropout layer right after we create a recurrent, just to make sure that we don't run into any problems of overfitting or where a model just starts predicting one thing, gets kind of set in a path. And so the dropout layer is just so important to make sure our model stays diverse and doesn't concentrate on one path through the network, finds a diverse set of paths. Okay. So we created the time layer out here that coming out of this if statement. So we're going to go dropout layer times time equals to time. Okay. Not exactly, but that's the way it reads is just this is what it is. So this is the output of this dropout function with all of these other functions performed on the inside and here. So we're kind of just not sequential, but we're stacking these almost is a good way to think of this. Okay, then we're going to do if, I said underscore because we're not going to use the value in that we're going to iterate through, but we're going to iterate through a certain number of times. So if value in range nums dense body. So nums dense body, I set it as 2. What this will do is we'll create 2 loops, then we'll loop through this twice, and every time we loop through this, we're going to go time equals to layers dot dense, and we're going to dense body neurons or activation. We're going to times this by time, or not times, we're going to put time next to this, and then we're going to go time on the way out again, and then layers, and then we're going to do a drop of layers. So after every dense layer, we're going to put a drop of layers is good practice to make sure that we don't run into any issues. Drop out and then time. So we're going to do this, and we're going to do this depending on the number of times we choose to. We're going to do 2 to get started, but we'll iterate. I did iterate through this to find the number that was a good fit. 2 turned out to be the number that was good, but I found that afterwards. I came back up here and changed it. Okay. So time. So here what we're going to do is layers and then we're going to do this by time again. So we're just working through the time channel here. But just notice we did this through so many, and then we're creating an individual dense layer for each channel. In the next layer, we're going to do an individual dropout layer for each channel. So we'll do time again, layers, and this is just, you have so much flexibility with how you build a functional model. That it's kind of good and bad because you almost have too much flexibility that it's kind of hard to figure out what is the best thing. Let's experiment, and that's why we're setting it up this way. Okay? So we're going to do these 3 layers. So we're going to do a dense and a dropout for each one of the layers. So we created 1 channel for the dense, then we just do 1 dense layer for everything, 1 dropout layer for everything. Then we're going to create a head. We're going to start combining the layers. So layers equals concatenate, and then we're going to put in time and economics. We're combining the time and the economic together. Then what we're doing after we combine those 2, what we're going to go do is head is equal to layers dot dense and activation here, and we're going to again in this one we're going to be putting in the head this time. So change our layer name. We concatenate these together just to help keep track of this. Change the name here, so head is now going to be the main branch of our data that we're working. Okay. Here what we're going to do again is head is coming out of this, so dropout and head by the dropout layer. So it's going to be processed inside of the dropout. Okay, so here what we're going to do is we're going to create a hat now. So it's like body, head, and then hat. I kind of ran out of names to call, but you could do maybe body, neck, and head. It might be a little bit better for the next time. But yeah, live and learn. So here what we're going to do is we're going to bind the head now with the trend. And so we're going to put the hat, we're going to process that next to a dense layer, just a dense layer with the dense hat activations, neurons and then activation. And then we're going to create an output layer. Now this is really important. So we combine everything and then we just have it one dense layer after we combined everything. Nothing super fancy. We're going to do 1 more dense layer to be our output. Okay, now this is a regression problem. So for an output, we just want 1 neuron. 1 neuron is kind of a natural linear regression that happens inside of each neuron. So this just works really well for our output. And so we're not going to give it an activation, but we're going to give it a name because we need to give our inputs and our outputs names. Very important so that we can reference them. Okay. So then what we're going to do here, so I'm going to give my inputs. So I'm going to say input. So we haven't initialized our model anymore. We just created layers, right? Normally in the sequential, you start with the sequential and you put layers inside it. Here we start with the layers and then we're going to put the inputs and outputs into our model. Okay. So this is going to be inputs. This is the S, expecting a list, and it's going to be a list of our inputs, and this would be time. And then economic and trend. We're going to do outputs. We only have 1 output, but we could have more than 1. So outputs, always remember this S, and we're just going to say we called it output. Okay. Then we're going to do our compiler model like we always do. So we're going to go loss equals ls, which is our loss function. optimizer equals optimizer. And then here we're going to use the TensorFlow add-on library. So remember it's tfa.metrics.r². And then after all of that, what we want to do is this initializes our model. It essentially creates the architecture. So we're going to return from this model factory our model. Okay, and we didn't get an error when we ran that big function, but that will just make our life so much easier now and make our coding so much easier. So if we then run this, choose initializes, yeah, oh, that would be one thing that I got. So I did this. So just to show you what I was looking at. There's a good, sucks that I make a mistake, but it happens. So local variable reference before assignment. I was confused when I first saw this. I have never seen this error before because I never made this mistake before. Normally I think a little bit more before I start writing, but when you're writing on YouTube, it's a little bit, writing code in front of a whole audience, a little bit more intimidating. I did if here. So I did if in range. So I thought like this should be a variable, but I really actually want to say for nothing. So that we're not going to use this variable in our thing. For in range number this. So we're going to just repeat these actions the number of times. So for this. Okay, so if we run this now, we should hopefully get our model initialized. So everything's working good. Now we can see our model, which is pretty cool. So we're taking the time layer, goes through an LSTM, dropout dense, and we will be able to change how many of these are. Then we have the input of the economic layer, goes through an LSTM layer, then a dropout, then a dense, then dropout again. And then they combine. Okay. And then we have a dense layer for those two. And then the dropout layer. And then we have over here an input layer for our trend data, an input layer for LSTM layer for our input, dense layer for our economic and time series, another dropout, dense, dropout, dropout, dense, dropout. And then we're concatenating those layers. So we're putting all three of them together. And then we have our one dense layer. And then we're having the one output layer right here. So nice kind of cool way that we combine data. It really depends. I figured there were probably more kind of higher level patterns in the time series. We had a lot more data, a lot of more interactions. We had a lot less data for the trend. And because it's going to be the same value during the week, I thought it would just be, there's not so much complexity there, I guess I would say. I just thought it would be a little bit better to be sending it through less of a channel, which is kind of decomposition of the data. And so we didn't really need that right there. So there we got our model bits. Okay, so then we'll do model equals to model factory inside. So we're going to set experiments now. So we built the model. Now we're going to set up the thing that's going to redo all our experiments. So just noticing here, I'm giving it recurrent nums is going to be taking in this recurrent nums, recurrent act is going to be taking in this recurrent act. So whatever the outside function is set to, this experiments, the inside one is going to take in. Right? So this is really important. You have to connect these two together. Okay. So then we're going to do in the next line some model factory, and we're going to go history equals to model dot fit. Okay. So then what we're going to do is we're going to set what are our inputs right here. Right? So we're going to say input. So we give it our layers up above, but our layers have names, and so we need to say now input time is equal to input tr underscore time. And then we're going to say our epochs are equal to our EPS, so epochs. And then we're going to do validation. Validation data. Okay, validation data. We're going to set verbose equals to 2. I think I usually set this as 0 when I'm doing experiments. 1 gives you the full printout of every epoch. It's a little bit too much. So I just, usually you might find setting this as 0 might be fun for the experiments down below, but we're not going to do this today. So play around with this, but this is where you could change how much is displayed when it's training, when your model is training, okay? Bat size, I'm going to use a smaller bat size because that should give us a better prediction. It's going to take longer to train, but it should give us a better prediction. Okay. So here we're going to do a really easy way to plot the history is to put it into a data frame. So pd.dataframe, and we're going to put history.history inside of this. History. And we're going to plot. We're going to give it our random colors. We're going to go subplots is equal to 4, and we're going to say our layout is equal to 4 by 1. So it's all going to be an index right here. Big size 12 by 6, and then we're going to go plot, because we're doing this in a loop, so we want to make sure that we're displaying our model. Then we're going to go model.evaluate. So we're doing both of those right here. And again, we're giving it a dictionary of our inputs, input time, the name of our layer, input layer, and the name and the data we're giving it. Right? So these should match up in terms of the width and size and stuff like that. And so we took the length of the features that went into this to set the value. So you'd be able to change the length of the features, maybe take out some of the features in the lists up above, comment them out, and everything should still work going forward. Okay. And this is just the line plot that we built last time, which will summarize all of the scores in the final model. So let's start this and make sure this is running. Okay, so we're not getting any errors. So this is going to take a long time. I trained this for 700, and this is with the verbose took. So this will just see this every time, so you get a sense of where it's printing. So I ran this one time, and this is the final model that I got after I went and did all the experiment stuff. I'll just quickly go through that with you. But this is what I found. I did not train it for 100 or 700 in all the models. I kept training. You can see this keeps increasing. If you go to 800, something bad happens. But 700 seems like a good amount to train this from. And we got not a great score, but we got a 16, an R squared of 16.16, which is getting not predictive exactly, but getting supportive in our decisions. So we're getting there. We're working up to this. So the best I've ever been able to do is a 0.3 R squared. So the data we have isn't everything that we could have, but it's a good start. So we should be able to get this. I would shoot for 0.2, and then we start looking for other data that we can get with R squared. But really good news, we're getting more predictive. Okay. So then just to walk you through an experiment, let's do one that ran. So here I create two lists. So score train, score test, what we're going to be iterating through, which is this variables right here. So our activations, set up our model experiments right here. I'm going to pass the variable. And the thing is here is what I'm going to be doing is right here. So when our act body, the activation function from our body for the recurrent layers is this, or this. It's going to try all 4 of these as it trains this. And we can see, different, some models work better. Some activations work quite a bit better than others. Let's just go look at the bottom one. And so you can see here, ALU worked the best. 10H did okay. RayLu did okay as well. I like ALU's my favorite, truthfully. And then SALU, truthfully, I never really find that works well, but I want to test everything, see what works the best. And you can see here we don't get a very good score. But now we can see, now we have our test. And so I would say the ALU. And then in the next one down here, I would be using ALU activation, and then I'd be trying the recurrent type. And then go through those. And I did all of these, lots of these. And that's how I ended up with this final model. This is not what I started with. This is what I got to afterwards. Okay. So thank you so much for joining me, and I will see you next time. So have a great day. Bye.